Hello everybody, this is the Skill 23 notes that we're going to be using in class today, and that is going to cover solving polynomial equations. Okay, I stole this from a site that I like, so I wanted to use this sheet, but I want you to know that it's Skill 23. Alright. So, it says we've been helping Miss Gallus's neighbor, 4th grader Polly. Polly has an older brother, polynomial. Polynomial. Anyway, he's learning about solving equations in his, I should say, Algebra 2 class. And we're going to help him with some homework before we begin. Actually, no, that was his Algebra 1 class, because he's learning stuff that's Algebra 1, but we're going to use that to help us understand our Algebra 2 content. Anyway, Polly needs to do these two problems for his homework. Solve each problem for x and show or explain how you got the answer. Okay, looking at this first one, since I just have the x squared, I'm probably just going to solve this by inverse operations. So I'm going to add 100 to both sides, and we get 2x squared equals 100. Divide by 2, and we get x squared equals 50. Take the square root of both sides. And let's see, square root of 50, I can take out 25 and 2, and then 25 is 5 and 5. So I end up with a pair of 5s. So x will be plus or minus 5, and then the leftover 2 is in the radical. Okay, two solutions. This next one, x squared plus 4x plus 16. Let's see, thinking of things that multiply to 16, 1 and 16, 2 and 8, 4 and 4. None of those are going to add to 4. So what that means is this does not factor. So we're going to use the quadratic formula, okay? So quadratic formula, a is 1, b is 4, c is 16. Okay, so to solve this, we're going to get, I'm going to make my little template here. And I can already tell from doing this that we're going to get imaginary answers. Then they give us -4 plus or minus square root. Underneath, we're going to get 16 minus 64. Which is -48 all over 2. Square root of -48, we know we're going to end up with an I. And let's see, 48, I can do 12 and 4. 12 is 2 and 6, and then I get 2 and 2, and then 2 and 3. So a pair of 2's and another pair of 2's. So that'll be 4i radical 3 all over the leftover 2, or not the leftover, but the denominator of 2. And when we simplify that, we could divide the -4, the 4, and the 2 by 2. So we're going to get -2 plus or minus 2i radical 3. That'll be over 1. There's our two solutions. They are imaginary solutions. Okay? So Polly thinks that all quadratics can be solved by factoring. Oops, sorry. Is that true? No, as we just saw in example B, this quadratic did not factor. Okay, so let's show Polly how we can use these ideas to solve polynomials also. So the polynomial 2x cubed minus 6x squared minus 100x plus 300 has a factor of x minus 3. So what we're going to do is find all the solutions to this equation. Alright, so they told us that we have a factor of x minus 3, so that means synthetic division. So we're going to practice that. X minus 3 means we put x equals 3 on the outside. Our polynomial, we have x cubed, x squared, x constant. And so that means I can write my coefficients. Okay. Drop down the first one. 2 times 3, we get 6. 0 times 3 is 0. Negative 100 times 3 is negative 300. So we end up with a remainder of 0. And so we had x to the third. This 2 now becomes the coefficient to 2x squared. I don't need to write the 0x terms, so I'm going to put 100. And look at that. That equation, 2x squared minus 100, is going to be that exact equation that we solved a moment ago. So 2x squared minus 100 equals 0, which means 2x squared is 100, which means x squared is 50. And we already did all of this earlier, so I'm just going to refer you back to problem A. We're going to get x equals plus or minus 5 radical 2. So the solutions are, so we're going to have x equals 3. That came from being told that we had a factor of x minus 3. And then we're also going to have x equals 5 radical 2 and x equals negative 5 radical 2. And when we look here, we have 3 solutions, and our polynomial had a degree of 3. So keep that in mind. Now, if we were to look at this equation, if we were to graph that, I'm going to pull this up on Desmos real quick. Maybe. So I'm going to pull this up on Desmos. And it's going to take a pleasant amount of time to do. Come on. Come along now. There we go. Okay. So sorry. Trying to get this out of the way so I can see the problem. So if we graphed y equals 2x cubed minus 6x squared minus 100x plus 300, we can see that there are 3 x-intercepts. And here they are. Negative 7.071. You might be wondering, well, what in the world is that? Well, let's see what square root of, or 5 times square root of 2 is. So let me pull up a calculator. Maybe. Try it again. Okay, so looking at this, we're gonna, oh, come on. Everything's being weird today. All right, so I'm gonna take square root of 2 and multiply it by 5. And that gets us 7.071, which we see that solution. And if we had a negative, then it would just be negative 7.071. Okay? So now what you should note is there are 3 x-intercepts, which we're also going to call zeros, because the degree is 3. And that would be the highest exponent. Okay? All right, let's try another one here. So if I look at this next one, I'm going to use a different color here. We have this equation, and we're told that it has a 0 that's at x equals negative 1. So I want to find all the zeros. Well, I'm going to go ahead and write x equals negative 1 because we were told that. And because they already tell us the 0, we don't have to do the opposite of the negative 1. So we're just going to put the negative 1 in the parentheses, or in the outside rather. Let's see, x cubed, x squared, x constant. We're not missing any terms, and they're in the right order. So I'm just going to go ahead and write my coefficients, do my synthetic division. I'm doing this kind of quickly, so pause the video if you need a little more help with that. And we end up with x squared plus 4x plus 16. Oh, look, that looks like what we had up here. So we already know, so look at example B. the solutions are x equals 2 plus, or no, negative 2. I think it was negative 2. Negative 2 plus or minus 2i radical 3. So my other zeros are negative 2 plus 2i radical 3 and negative 2 minus 2i radical 3. Okay? Now if I were to graph this, let's see what happens when we graph it. I wish now I hadn't closed out Desmos. But at least it's going quicker now. Okay, so I'm going to graph this equation. Y equals x cubed plus 5x squared plus 20x plus 16. Okay, looking at this, you might think, our degree was 3, but I only see it's crossing the x-axis in one spot, and it's happening at the x value of negative 1. Okay? So there's one x-intercept, and then there are two imaginary zeros. And these don't cross x-axis. Okay? So if you think back to when we did the discriminant, on the discriminant for a quadratic, you may remember we had those three scenarios. If the square root was positive, we had 2 real solutions. If the square root was 0, we had 1 real. And if the square root was negative, we had no real solutions. And what that meant was that it was the number of x-intercepts that we had. So if you have imaginary solutions, which is what this I is all about, if you have imaginary solutions, then they're not going to cross the x-axis. So our number of zeros, 3 zeros, match the degree, but it doesn't have to always mean that it'll cross the x-axis 3 times. All right. Okay, so for our key ideas, this is going to be really important. The first thing we need to know is that you can graph a polynomial to find x-intercepts, also known as zeros. Okay? We look for output of 0 to find x-intercept. So in other words, we set our equation equal to 0. Okay? And then we turn the 0 or the x-intercept into a factor. Okay? That's how we identify zeros as, or identify factors or zeros. So all of that is how you can tell where they are. The other one is about solving polynomials. To solve polynomials, first of all, the number of solutions is equal to the degree. So you can use graph, table, or given info to find any solutions. Okay? Divide the polynomial by all factors, and then solve the resulting equation. So methods for solving: These are going to be important. We've learned all of them. Factoring. Complete the square. You could also use quadratic formula. You can also use graphing. And you can use inverse operations. Okay, so we saw all of those, and now what we're going to do is a couple check for understanding problems. Okay? All right, so it says a table of selected values is given for this function right here, and we want to solve this equation right here. Okay, the first thing we want to look for is when is f of x equal to 0? And note this happens here at 8. So what we're going to do is we're going to divide this polynomial by that x equals 8. So I'm going to put 8. And I'm going to look at this polynomial. 1, negative 6, negative 40, and 192. 1 times 8 is 8. 2 times 8 is 16. Let's see, 40 minus 16, negative 24. Negative 24 times 8, I'm guessing, is going to be 192. And it is negative 192. So that gives us x squared plus 2x minus 24. So now I look at that and I think, what can I multiply to get negative 24 and add to get 2? I can use 6 and negative 4, so we can factor this. So I'll write this as x squared plus 6x minus 4x minus 24 and use my grouping. I can factor out an x in the first group. Actually, let me do this a different way. Not a different way, but so we'll have x in the first group and negative 4 in the second group. So x minus 4. And our groups are x plus 6 when we write them over. Everything's linear now, so let's identify our zeros. So we knew x equals 8. When x minus 4 equals 0, we get x equals 4. And when x plus 6 equals 0, we get x equals negative 6. So these are our zeros. Okay? All right. Next one, we have a graph here. On this one, I see there are 4 x-intercepts, but I can only distinctly tell 2 of them. I know that x equals negative 3 is good. And I know x equals, I don't have to keep writing x equals. We also know x equals 1, but there are 2 others that we need to figure out. And because these are not nice values here, most likely we're going to have to solve those using the quadratic formula. So let's look at what we got. We have this polynomial. We know x equals negative 3 is a 0. So I'm going to use synthetic division, figure that out. That gives me x cubed minus x squared minus 2x plus 2. So we can factor that by grouping. Or you could also use that 1. Let's see, we can divide those by x squared and then here by minus 2. So we get x squared minus 2 as a factor. And we'd get x plus 1, or no, x minus 1 left over. Okay. We can set those equal to 0. This one will just be x equals 1, which we already knew. Now for the x squared minus 2, let me do that differently. X squared minus 2 equals 0 means x squared equals 2. So x equals plus or minus radical 2. And that's what these solutions had to have been. So actually, I didn't need to put that 1 again. All right, so that's how we're going to solve a polynomial equation. Now in class, we're going to do several examples, so please don't freak out if this seems a little crazy right now, but we are going to practice these and you will become better at it.